Okej, cześć, to pytanie, bo any English speaking people now? Może być po polsku? Bo tak dostałem od organizatorów, że jeżeli nikt nie protestuje, to mówię po polsku. A ponieważ mam bardzo mało czasu i nie mogę się powtarzać, to będę jechał po polsku tak szybko, jak się da. Kolejny język programowania. Jarek Ratajski, to już byłem zapowiedziany, pracuję w takiej firmie Engenius w Szwajcarii. Jak ktoś by chciał pracować ze mną w Szwajcarii, to rekrutujemy. Oprócz tego zachęcam, jest tu parę fajnych firm, które znam, które też rekrutują, także podejdźcie. Skąd się wzięła idea tej prezentacji? Jestem aktywnym uczestnikiem takiego forum forprogrammers.net. Kto zna? Ręka w górę? No niewiele, jak ktoś jeszcze... O nie, to dużo już was zna. Świetnie, polecam. To mówią na to polski Stack Overflow, co nie jest do końca prawdą, bo to jest techniczne, ale też to jest tak naprawdę taka społeczność fajna. Ja tam się udzielam, nie tylko ja, poznacie wielu fajnych ludzi, jak tam będziecie, ale co jakiś czas zdarzy się ten tak zwany drama post. Drama post polega na tym, że ktoś przychodzi i mówi tak, no mam 30 lat, żonę, dzieci, a tutaj pracuję jako programista i ciągle nowe języki, ciągle nowe frameworki. Come on. If anyone doesn't understand Polish, then you. Okay, so I'll switch to English right now. Sorry for that. So I'm talking about another language and a problem that people basically get tired of it, that they need to learn new frameworks, new languages, and what they're gonna do. So those are kind of problems people arise, like why new languages, why new frameworks? Does it ever end? Yeah, this is the problem. Maybe they should jump to other position. You cannot be developer for maybe 20 years, because who can learn for 20 years constantly? Yeah, that's the problem. So now, slowly, who remembers his first programming language here? By the way, who is a software developer here? Who knows programming here? Okay, almost everybody, great. Now, this is my first programming language. Do you recognize it? Basic, of course. Okay, that was beginning of 90s, and that was my favorite language. But of course, you have your favorite programming languages, and you know what's the favorite programming language? It's something that you know, you like, but even more important, you dislike the others. Really, that's very important. It's not what we like, but whom we disregard. And you would do everything in that language. So now, think of this language, your favorite one, and shout it. Shout it, please, okay? PHP. No. Why? Okay. I thought it was obvious. Okay. There is a really nice page called 99 Bottles of Beer. Who knows this page? It is an internet page where there is a simple algorithm written in as many languages as you can imagine. And there are, some time ago, there were more than 1,500 of implementations of a simple, very simple algorithm. I even have two posts there, like I found some ideas and put two other implementations. It means if you find a new language or something that it's not even a programming language, but you accidentally find out that you can implement algorithm on your fridge or maybe using your wash machine, then post it there, and it will be okay. So how did it end like that? That we have so many languages right now? Let's start from the beginning, from the first computers ever. Do you know what was like the first computer? Shout me. What? Okay. Do you recognize this machine? Which century it is? Okay, this is 19th century. Analytical engine. Okay, this is a little bit, I cheated a little. This was first planned computer and designed as a computer, but actually never worked because it was at that time technically almost impossible to create it working. But if you are into steampunk, you know what a steampunk is, the like fashion. It is like ultimate, opus magnum of a steampunk world. The computer powered by steam engine. Yeah, really cool. But it actually was supposed to work more or less like a modern computers, really, with central processing unit kind of, and with programming. And this is actually first program, one of the first programs written, it wasn't written like that. Actually, it was written more like a diagram, but let's say the code of this program would look like this, transpiled to the modern engine. And you know who wrote this program? Who was the first software developer? Of course, this lady. So this is a more complex story, but nevertheless, this is really old one and very, how to say, inspiring and interesting. So if you have time, read about it. There are a couple of books. Okay, and then, did you ever hear about it? About this one? 1939. I bet no, this is a very unknown story. You probably heard about other computers, but this is from the United States, and it's using like electro switches, first that uses electricity, but it's still partially mechanical. And then there was another one, and if you are working with German people, it's good to know it, because then they will love you when you mention that. Mind the date. You probably haven't heard about it, because, you know, Berlin, 1941, used for, I think, artillery calculations and stuff like that. It wasn't after the war very, let's say, politically polite to even mention that. So it was largely forgotten, Konrad Zuse idea, but this is also considered a valid computer. And then all the other stuff, you know. By the way, Zuse also created something that is considered a high-level programming language, but I will not talk about it, even though it was very interesting, because it didn't play any role. Again, for political reason, he was kind of forgotten. And then the story you probably know, Colossus, ENIAC, EDVAC, BINAC, that's, let's say, popular articles are describing about. But actually, this story started, as you see, long before. And that's how programming looked like back then. One thing, do you see very important thing on this? If you look at the photos at that time, from that time, you will see that software developers were mostly women. This is really like that. You see just, yeah, because that was tough back then. So, and, you know, programming was really like, you didn't have a text editor or stuff like that. You had to switch some switches and, yeah, put the very precisely and accurately the program. So this was really like, yeah, that was also, let's say, kind of a sport-like job. You were doing a lot of walks while programming. Yeah, it wasn't a sitting job. Interesting. However, I cannot present you. It would take time to present you how programming back then looked really like, but we can represent this kind of programming with a modern example from, let's say, 30 years after ENIAC. The code would look like this. And can you tell me what this program does? No, you cannot. Okay, I will make it easier. This is for this CPU. It is now obvious. It isn't. Okay, you have to put it into this memory address. Now it should be kind of obvious. Nope. Okay, I can only, okay, make it even easier. Where is this? Just I don't see it. But F0, this is a conditional branch, so kind of like if statement. Now it should be easy what it does. No? And this is unconditional jump to this memory address, okay? So, you know what this language is? How do we call it? That's machine code, let's say internal language of a preprocessor. And yeah, that's it. And what is about this language? This is how actually machines work. The important thing is it's a very simple language. The rules of machine code are extremely simple. It's something you can teach, you know, in a primary school. Really, this is not a problem. The problem of this is that when you do jumps, conditional jumps, or all these numbers represent almost all of them, some codes, some orders for a computer, but those are numbers. It's hard for us humans to remember them, so you need a table, how to translate, and you have to remember. Back then I was programming like that, and on my machine had like 150 opcodes, and I could remember like maybe 50 of them. That was enough for programming. But it was, of course, not a funny job. It was kind of mechanical, boring. And so even though the language and the rules are very simple, it's hard to write any sensible program with that. So people decided that they need something better and another programming language. And they created this. That's the same code as you see before. Now it's totally readable. Everyone can find out what it does. Can you tell me? Okay, this is the same machine code presented in other form. Do you know what this language is? That's assembly. So there is a very small difference between machine code and assembly. Simply assembly is, let's say, machine code in a human readable form. That's it. And yeah, basically for people that cannot remember, like noobs. So, of course, it is as fast as machine code. That's why back then, when it was created, it was very popular. No one really cared. Jumping from machine code to assembly, everyone was happy. By the way, some programs actually are portable between different computers and architecture on an assembly language level. Of course, then you could write bigger programs, and you would see that there is a problem of registers hell. Like in any modern language, you have like variables. You can have multiple, like hundreds of variables. This is my name, username, database connection, string, whatever. And in assembly, typically you have registers, and you have like 6 of them, 5, even 3. Not much, and you have to remember what you use for what. And if you don't use it, you have to store it temporarily somewhere else in memory. And managing that was really a tricky job. And a lot of errors were done. And even arithmetic calculation, like you add 2 numbers in assembly. That can be like 100 opcodes, really. Depends on the processor. On the modern ones, actually, it's typically 1. But on the older ones, and if you did floats, it was really a big piece of code. And, of course, you needed comments, because otherwise it was hard to read it, what it does. Yeah, and with comments, it was obviously obvious what we are doing. Okay. But the hardware was changing, assembly became popular, and this thing was created. You know what is this? This is actually memory. You don't see how big it is, but I think it's less than kilobyte, and this was memory stored the bits in the waves of fluid, of mercury. This was really interesting. So you had to be patient while programming. If you stamped or you shouted too loud, you were erasing the memory. How cool. Okay, but this is actually the memory that was big enough to store bigger programs and to help us to write more complex programs. So it was opportunity to create something more sophisticated than assembly, and this language came. You know it? This is a FORTRAN. And FORTRAN was one of the first programming languages, high-level programming languages. It means we make a big jump from assembly. We no longer look at the machine code and assembly, like a machine code translated. We look, let's say, human readable form. And this was a language created for mathematicians. So people that were writing mathematical algorithms could easily translate this into their language. And it became very, very popular among scientists. Really cool thing about, for instance, about FORTRAN, I like it. When you have variable, you can use now any name, but if it starts from A, B, C, or something like that, it is float. It means it's real number. If it's, however, I, J, K, L, this would be integer. So, because mathematicians for a long time were using, let's say, variable names like that. And, okay. So this is the language. And mathematicians got their language. But then computers were used not also by scientists, but for people, let's say, from business or from military, for other purposes, not only scientific. And they actually learned that FORTRAN is, let's say, too scientific for them. They needed something like business-oriented. So they created another language, and this is like one of the creators, you know her? Grandma Cobble, Grace Hopper. And this is the language, so I already mentioned the name, the COBOL, Common Business Language, let's say, I've forgotten the full name. And you see one nice thing about it. Move, second number to display number, display, blah, 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 perform. You see one thing, it reads like an English. That was the first language you didn't need really comments, because it was self-explaining what you are doing. Cool. And however, it still was very close to machine code, because the translation from COBOL to machine language is actually not that tough, and it had extreme ceremony. If you think, for instance, Java is verbose, or any other language you write is verbose, you have to write a lot of lines. I can tell you that there are like researchers that say that you need 30 lines of COBOL to do what is possible in one line in Java, or even more. This is really cool. Okay, but we see the first reason why we create languages with that. Don't do boring stuff like transpiling, machine code, arithmetic expressions. Let's do everything that's kind of obvious and computer can do on his own. Let's do this boring part with a computer. Actually, this was created for that. So the compiler will do that for you. You will keep on thinking, and the compiler will do the boring stuff. Cool. That's why we have languages. So, but then hardware was changing. We had punch cards, where FORTRAN was mostly written on it. Then we had vacuum tubes, so faster hardware. And it was an opportunity to create another languages that were a little bit farther from machine code. Not that close, because we could do more sophisticated compilers or interpreters. And you know this language? This is a Lisp. Why? It's because this is, let's say, the first language that wasn't created late. We have a machine code, and now let's do this machine code easier for us. This was a language that starts actually in something called lambda calculus, so mathematical idea, and we do all, let's say, on the paper, and only at the end we think, maybe we can somehow write a compiler for it and run it on a computer. Sounds impossible, but let's try it. And actually it worked. However, it was never very popular. It was known for decades. It was used, but mostly by scientists. And in my opinion, didn't play very big role. Of course, it played some, but it never became a mainstream. However, this shows another reason for a new languages. We have just really cool ideas. We want to try something new, something maybe scientific, and now let's try if you can write a program if you can write a compiler for it, or a programming language. So, we'll not talk about Lisp, for the reason it wasn't that much used. And then people created this language, because mathematicians got their language, business people got their language, but the new branch of science was created, and they needed a language for them. You know this one? The new branch was computer science, and they wanted to write computer science algorithms, and they created language to write computer algorithms. And if you buy and if you read a book from 60s, from 70s about algorithms, I bet most of the algorithms would be written in this language of algorithms. Even now, this is ALGOL. Even the name suggests it. So basically it started as a better FORTRAN, then it was very popular version, ALGOL 60, and then there was a great disaster I will mention. Okay, I have to skip some parts. So ALGOL 68, really back then it looked like we have an ultimate language that everybody is satisfied of. Like, let's do everything in ALGOL, it has everything, but then people gathered, let's make this ALGOL even better. This was ALGOL 68, and a great committee of really big minds gathered, and they were starting to design, they have started to design a new language, new version of ALGOL. That's actually is a, let's say, example of what does it mean designed by a committee, actually, not community, I should have written. And they created, like, everyone wanted to put something, his own ideas into this language. So we had a language which was supporting like hundreds of ideas. And it was that tough that only years after it was designed, the first compiler appeared on the market. And it has tons of funny operators, you will see. Actually, this is like what you wanted, what you needed to write ALGOL 68, the keyboard. You know, all these symbols were used in defining a language. All those operators, arrow down, back, blah. And the problem is, at that time, that was how we were communicating with computer. Mind, like 28 keys, not really all those operators available. So that was like big mismatch. between what people created and what people could do at that time. So it ended as a disaster. However, the hardware was improving. You know what is this? I like it. This is the last memory piece where you could see each bit by your own eye. It's not really visible on this picture, but this is really core memory. And that was a transistor created, first one big, kind of big, but they were, let's say, still better than vacuum tubes. And from this moment, the computers started to lose, let's say, the limits. They could be really big and could store bigger programs. So that was like explosion of languages. And this language was created. I bet you don't know it, but it has this thing, this nasty thing, null. So it was ALGOL W. So when people seen the disaster of ALGOL, that it's coming, they created alternatives. So this is the Tony Hoare, the creator of null concept, and he calls it $1 billion mistake that we still fight with, and that's just an example. But then we had other languages, like this one. It's also because the ALGOL became disaster, and then people started to write something else. Mind these braces. You should see them in modern languages. You know this language? BCPL. This is like let's say, ancestor of C language. And the first one that used Hungarian notation. There was a need for that. And then another language, that's actually my first one. You should know it. This is a BASIC. And that's also a very interesting example, because BASIC had a new idea. Let's make programming for the masses. Not for a scientist, not for computer scientists, not for, let's say, business, military, just for everyone to make programming as a hobby. And BASIC was created for that and really worked. It was really nice to work because it had interpreters, so it means you were looking what you are doing as you go. You didn't have to compile your program and wait for that. You can just write line by line and see what's happening. Of course, then there were problems like exactly we have in FORTRAN, GoTo, HAL, etc. But the hardware was changing. This is a modern memory. Exactly then we had first processors. This looks like finally as the age that we have now. That was this computer. You know those guys? Yeah, they created a BASIC for this Altair. It's also a fascinating story. Everyone was doing BASIC and everyone was happy. And this guy, nasty one, came and said that GoTo is considered harmful. And I remember when I first heard that. What the hell? GoTo is the most important thing you do in a programming, like your jump. How can you program without GoTo? It is impossible. And people were really thinking like that. But the guy said, okay, GoTo makes your code a spaghetti-like. And he said that there should be other way. And he proposed structured programming. You know this one. You should recognize Pascal, really for years dominating in education. Structural programming, no more GoTo, variables had to be declared, etc. And this is the very important for me reason why we create a new programming languages. We want to prevent some errors so that we make less bugs. And then, because in structural programming, it is absolutely impossible to create spaghetti code. Yeah. But the hardware was changing, hard disk appeared, and then we had another programming language. This one you probably know, C. And I don't have much time because I have to end quickly. So let's say that was dominating for years, but had its own problem, like void stars and pointers. Well, it's really a hell. And then people created another programming language. That was my first functional programming language. You know it? C++. Of course, it's meant to be object-oriented. It was kind of object-oriented, but really supported also functional programming. And even new versions support it even better. So it was really cool. And I spent a couple of years really happily thinking that C++ is ultimate language. No one can create anything better, of course. But the hardware was changing, and we got internet and network. And C++ doesn't solve one problem, security. It's really a hell if you think about writing secure programs writing a servers in C++. It's possible, but it's dangerous. So people created another language. You recognize it? Java. This was, I still cannot understand. Okay, I will tell you. I switched from C++ to Java and think that could be written in one line in C++ was written in so many lines in Java. The Java 1.2 that became very popular, 1.3, was extremely verbose language and a huge step back compared to C++. However, it solved the security and other problems. Just to show you, this is how we write the same thing in a modern Java. That already solves some problem, and it's all more or less now as capable as C++. So Java brings multi-threading, security, so all that stuff you can do in C++, but it's hard. You have to be careful, and Java solves this. And there is a reason why Java became popular. For me, I'm sure, because I remember, Java became popular because it was the first really big language supported by a big company. The compiler and the tools were for free. So if I wanted to do commercial code, I would do that in Java back then. That was the reason my company switched to Java, and I switched to Java, really. Now it's obvious that everything you get for free as a software developer. You don't sell compilers. Okay, you sell, but it's, let's say, not a mainstream. But back then it was something new. And then there was a language that is the most successful ever. You should recognize it. This is a JavaScript. This is really a JavaScript, valid one. You can read about something called JSFuck. If you don't know, this is the author of the JavaScript. Yes, actually it was, the idea, the core of JavaScript is really nice, but it's kind of, because of a marketing reason and stuff like that, like compatibility with C, it is kind of a wasted chance. The language combines the beauty and ugliness into one. But there is one other reason why you need that. Because this is a niche, something specially designed, like JavaScript was designed for these machines, Internet of Things, back then for browsers. But really, then we have now JavaScripts on the servers, etc. But the hardware was changing. This is a processor with 2 cores. And what happened? Maybe we can have a language that will naturally support multiple cores. And that's why you have things like that right now. Functional programming languages, because in Haskell, for instance, that you write the code as if you would write it for one thread, but the compiler, actually runtime, automatically uses cores for you, safely. You don't worry about it. It's one big step from Java, that because you don't even care about multi-threading, compiler does it for you, safely. Okay, and then we have tons of JVM libraries. I have to skip JVM languages, so even now inside of JVM, we have tons of them. Okay, I will skip. One thing I would like you to know, that there are languages with dynamic types and static typing, and for instance, Java is in the middle, kind of static, but with some dynamically part. Haskell is very like here, and there are languages right from Haskell. And JavaScript, PHP are kind of like here. But the thing is, if you want to keep the same quality, you either write more tests or you have more types. In the extreme case, everything is done on compiler level with time system, and you barely need any tests. But of course, that's at the moment, let's say, more scientific thing than reality. Okay, I will skip that part because I don't have time. For instance, Kotlin, language that I am now programming mostly, solves the problem of null checks. And again, for safety, I can now program safer. This is okay. I will skip that because this is for programmers. Let's go to the end. So lots of languages like Haskell and all that stuff, they make things safer, make unsafe code impossible. But there is also one other thing. I learned it while actually learning Haskell. The languages change the way you think. Like those guys, Inuits, they have like 400 names for a snow, what we know as a snow. Actually, you cannot find the vocabulary because most of them are not really polite to say loudly. You know, if you live in a snow, you don't have nice words to that. Well, I can understand it. But nevertheless, if you jump to other language, you learn completely new vocabulary that sometimes is even usable in the old one, but you didn't think of things like that. So, okay. And it's not that simple that you just learn language. Maybe if you learn a language, if you slowly learn, you become better. This is like, let's say, time and being good at a language. And if you start learning another language, there is one really nice thing, that at the beginning you are struggling, and then you're slowly getting that, but But then, in your old language, for instance, I was a Java programmer and I started to learn Haskell, and I realized I am now a little bit better Java programmer because I can port some of a solution from Haskell. This is really a cool thing. People don't think about it. And then I became better at Haskell, and then this happened. I don't want to do Java anymore. This is a horrible part. You have to be aware of that. But nevertheless, try on a small scale. Don't go, I don't know, if you learn a language, don't go with a production with that, with a new language. Typically, there are a lot of small things you can do, trainings, prototypes, hackathons. If you do have hackathons in a company, and the company is Java-oriented, why do you do hackathons with Java? That's a wasted chance. Do it with something else, with a frameworks that you don't use on your 8 hours job, yeah, a day. Learn different languages, like switching from C# to Java, it's no point. That's the same language, different, let's say, version. And what about boring architects that prevent you from using new languages? Grace Hopper, the grandma COBOL, she said, it's easier to ask for forgiveness than it's to get permission. Remember that. So just do it and forgive later. Will we ever have an ultimate language? I say no, because typically we have new hardware that we can try the new ideas with that, and then we create new bugs. And we'll see new bugs, then we want to catch them with, let's say, some ceremony. And when we do that, we see that we have too much ceremony, so we simplify, and by the end, this cycle is over. We have a new hardware, new possibilities, and of course, those are arrows between. So that I think this cycle will be going on. And if you are thinking, okay, you want to just keep on family, you can do that. Still, I work with people that learned COBOL back then and are doing that. But don't say a new team of young developers what they should do because you learned Java 1.4 15 years ago. Okay? There is a lot of things for you to do, but just please know what you know. And of course, there is other part, safe early adopters as me. We should help others create such presentations, convince why we want to use a new language, and that's it. Yeah. By the way, the languages are not created to make your life a disaster. They actually, as I shown you, make it faster and make it safer so that you can sleep during the weekend easily because there will be no more null pointer exceptions on production or things like that. That's why you want them. Okay, and thank you.